All right, let's dive in. We're going to demystify something that's, well, it's completely changing our world. Large language models, or LLMs, as you've probably heard them called. We're going to look at the whole blueprint, from how these massive digital minds are even built, all the way to how we can actually have a good conversation with them.
So it really all boils down to this one kind of sci-fi question, right? How in the world do you teach a computer to be, well, creative, to actually understand what we're saying, come up with new ideas on its own? That's the big mystery we're going to pull apart today.
Okay, so first things first, let's start with the blueprint. What are we actually talking about when we use that term large language model? Well, at its core, an LLM is kind of what it says on the tin. Let's just break that down. It's large because we're talking about a truly massive neural network. It's a language model because it's trained on just an insane amount of text. And model, well, that's because its whole job is to understand and generate our language, to make it possible to actually talk with a machine.
So what's the secret sauce here? Well, most of the big models you've heard of, like GPT, Llama, they're all built on something called a decoder-only transformer architecture. Now that sounds complicated, but its job is surprisingly simple. It's designed to do one thing really, really well, and that's predicting the next word in a sentence. That's it. That simple-sounding skill, that's the magic that lets them string together sentences that actually make sense.
Okay, so we've got the blueprint. But how do you go from a blueprint to, well, that? How do you build this digital giant? This brings us to the first and honestly the most massive step, pre-training. This is where we forge a powerful, all-knowing, well, generalist mind. See, building one of these things is like a 3-ingredient recipe, and you have to scale up all 3 ingredients at the same time. You need a ridiculous amount of training data. You need a massive model size, which we measure in something called parameters. And you need just an unbelievable amount of computer power to crunch all of it. So let's talk about what scale really looks like. First up, data. The biggest Llama 3.1 model was trained on, get this, 15 times trillion tokens. A token is basically a word, or sometimes just a piece of a word. 15 trillion. To even try to wrap your head around that, it's like reading every single book ever written and then doing it again and again many times over. The scale is just, it's mind-boggling. All right, next ingredient, model size. That same model has 405 billion parameters. Now, you can think of parameters as being kind of like the neurons in a digital brain. Every time the model learns something new, it's just tweaking those connections. So the more parameters you have, the more complex the ideas and the nuances of language you can actually understand. And the final piece of the puzzle, raw computer power. To build this thing, it took something like 16,000 of the most powerful GPUs on the planet, all working together. We're not talking about your gaming PC here. This is a massive industrial-scale operation just to create one of these base models from scratch. Okay, so after all that, what do we have? We have a model that's a generalist. It knows a little bit about, well, everything. It's like a brilliant college grad. But what if you don't need a generalist? What if you need a brain surgeon or a software engineer or a customer service expert? That's where the next step comes in. It's time to create a specialist. And this really breaks it down perfectly. Think of pre-training as forcing a student to read the entire library, every single book, to get a general sense of the world. Then fine-tuning. That's like taking that same student and enrolling them in a specialist masterclass. You give them one highly focused textbook to make them an expert in a single specific field. Now, this whole fine-tuning thing sounds awesome, right? But there's a big problem. Even this quote-unquote smaller step needs a ton of resources. So how can regular developers or researchers actually tweak these massive models? I mean, not everyone has a supercomputer in their basement, right? Let me put the problem into a single number for you. To fully fine-tune what's considered a small model, one with 7 billion parameters, you'd need a graphics card with at least 112 gigabytes of VRAM. Your high-end gaming card might have, 16, 24? So yeah, that's a huge barrier for most people. We needed a smarter way to do this. And that smarter way, it's a really clever technique called LoRA. Here's the big idea. Instead of trying to change all 7 billion of those parameters, LoRA just freezes the entire original model. locks it down. Then it injects these tiny, brand new layers into it. We call them adapters. The best analogy, it's like instead of rewriting whole textbook, you just add a bunch of little editable sticky notes to the pages. This is a game changer because it means pretty much anyone can now build their own specialized models. And the process itself is just beautiful in its simplicity. Step 1, you freeze that huge base model. Nothing changes. Step 2, you inject those little adapter layers. Step 3, you do your training. But, and this is the key, you only train the tiny adapters. And since they have so few parameters, the amount of memory you need just plummets. Then for the final step, you just merge your newly trained sticky notes back into the original model. And boom, you've got your new specialist. Okay, so we've built the model, we've specialized it. Now for the fun part, right? Actually talking to it. But here's the thing, getting the answer you really want, it's not always as simple as just asking. It's actually more of an art form. And this brings us to this really powerful idea called in-context learning. Basically, it means you can steer the model's behavior right there in the middle of your conversation. How? By giving it instructions and, this is the most important part, giving it examples of what you're looking for, all inside the prompt you send. The best part? No retraining needed. This is all happening on the fly. The most basic way to do this is what we call a zero-shot prompt. You literally just give it an instruction and cross your fingers hoping its general knowledge is good enough. You're giving it 0 examples to work with. That's where the name comes from. And, sometimes it works, but we can definitely do better. So the next level up is the one-shot prompt. It's simple. You give the model the instruction plus one really clear example of the right answer. Just that one little example can be enough to anchor its understanding, and you start getting way more reliable results. But really, the gold standard, the pro move, is the few-shot prompt. This is where you give it a few different examples, showing it the pattern you want. By showing it, if I give you this, I want you to give me that, the model gets so much better at figuring out what to do with your new request. Honestly, this is usually the secret to getting really high-quality answers. And this whole process, carefully picking your words, tweaking your instructions, finding just the right examples to show the model what you mean, that all has a name. It's called prompt engineering. It's the human skill of becoming a master conversationalist with these incredibly powerful AI tools. So there you have it. We've gone from the basic blueprint and the absolutely insane scale of pre-training, all the way to the clever hacks for fine-tuning and the art of just having a good conversation with an AI. You now know the basic recipe for how these things work. So the only real question left is, what are you going to build?